Okay, so this session, this webinar is all about real-time analytics with Kafka, and for Kafka, we are using different type of processing engines in for real-time processing. So we are taking example of Spark for those integration purpose, and this is what agenda we have for today's session, today's webinar. The first, like, what is Kafka, why we need Kafka, and Kafka components. So basically these 4 5 topics are about what is Kafka and how Kafka works, and how we are integrating the Kafka with different real-time processing technologies, and also why Kafka is such a better tool in real-time data pipeline when you're processing real-time data. So why Kafka is one of the most critical component in your real-time processing data pipeline, and why it is better than any other message brokers or messaging uh, queue. That's all about Kafka, and something about Kafka, like what are the companies who are using Kafka, and then the integration part. Some hands-on demo will start at the end of the session, so we can see like how easy it is to work with Kafka and how easily you can integrate Kafka within your real-time data pipeline. So first is like, why Kafka? Okay, so why Kafka when we have other messaging systems are not they good? So this the first I'll explain you what is Kafka. So basically, Kafka is a message broker, is a distributed, reliable message broker system. So message, when you heard the term message broker, you always feel like, okay, there are so many message brokers like ActiveMQ, RevitMQ, ZeroMQ, and HornetQ. So there are so many. Then why we need this particular Kafka for the real-time data pipeline? Can we use the existing one, because we already have those skills? The guys, the developers who are working already, or the testers who are already working with those message queues in their real-time applications. So it's easy for them to switch to use those same messaging application, and they can start for real-time data pipeline also. Thanks everybody. Okay, so this is something like now we can start thinking about like why Kafka when we have so many different messaging systems. So the point is, when you talk about real-time data analytics or real-time processing, we do have message brokers, ActiveMQ and RevitMQ and others. They are good, they are very good, but we need to think in real-time application, real time, when you are getting a lot of loads of data, and you want to analyze that data with through some tool, and also you want to hold the data for some time. Okay, and the data which is coming at very high speed, the very high velocity. So if the people who has now already learned the big data and Hadoop, if they know, this is a type of property of big data. When you're saying this data is a big data, so either this data come through four properties, either it's with huge velocity, or it's huge volume, or its variety, and then complexity of the data. So this is a particular category of a big data when you are receiving a very huge volume of data, and to store that data your normal ActiveMQ and RabbitMQ are not sufficient, or holding the data for some time they are not sufficient. Okay, so there's a question like, what is full form of Kafka? So basically, Kafka is a name. Kafka is a name of the one of the historian, or I think movie character. So this, in Hadoop or in Apache Hadoop ecosystem, the name of those projects, they do not have a exact like something similar to their work what they are doing, but this is something general terms. Like Hadoop is something which the duck cutting son was calling a elephant as a Hadoop, so that's why this product he started calling that project as a Hadoop. Similarly, Kafka is also a person, but it has nothing to do with your message broker. This is just a name. They all are good. They're all your all messaging systems are good, but they are not good for real-time data analytics, because there we are receiving data at very high speed, and with those messaging queues and message brokers, we may lose some data, but Kafka broker is giving you 100% reliability. You will not lose any data with maximum parallelism. With maximum parallelism. So this is something which are use cases for your Kafka. Transportation of logs. So what exactly transportation of log is? You have so many different servers where there are different servers where you keep on generating the logs. It could be your application logs, it could be your matrix, it could be a system or application or JVM matrix also, which are getting which are coming after every milliseconds, after 5-10 milliseconds window. So 5 second 10 or 5 or 10 millisecond window means this the speed of the data is very huge. They keep on coming. So these kind of logs you can push to Kafka can hold, and they can provide you support to hold the data. Activity stream in real time. This is something which your user is doing in real time. So how many users are there and what they are doing in the real time to your application, what are the links they are clicking, what are the products they are checking, for example of e-commerce. So all the data, these are the examples. In these examples, what they are trying to say as a use case is that the flow of data is very huge. The velocity of data is very huge. So activity stream is one of the case where there are n number of users, online users, and they all are doing something, and you want to analyze all the activity for that part. So as a data pipeline build tool, you can use Kafka to provide the data to your processing engines, where you can analyze the clicks. Collection of performance metrics. Just now I was talking about CPU or input output or memory or network or your number of threads or JVM data, like number of threads, free threads, how many threads are there, who are in which state, how many threads are there. So all those metrics which you're getting in the runtime system, those metrics generally they will come at very low window. Means you keep on pushing those metrics to monitor your system. And application specific also metrics, like time taken to load a web page, time taken by a multiple service when building a web page. So these all application specific are your particular application, not with the JVM, but your particular application. So in your application you may have a lot of statistics, and you want to see those statistics also in the real time. There's so many applications where people have their own statistics code. They will write there like how many users I'm receiving in this particular hour, and how many of them are going for which service by their statistics. So that way your application specific statistics. So in your system is having load of 100 or 500 users, then probably you are getting so much of log clients statistics every minute. Just example of number of HTTP web requests, how many web requests you're getting, or number of hits on a particular page or URL. So these all are use cases which all are telling one thing: the data which is coming at very high speed. Okay, some questions, guys. In which use case we use Kafka? Okay, so Dilip, I hope you got the answer. After what are my use cases? Pradeep, is Kafka works with on on Hadoop ecosystem? If yes, where it fit? Okay, and with the Storm also we can do Dilip, yeah, real time streaming. So a question from Pradeep is like, can we use Kafka on top of Hadoop or with Hadoop ecosystem? The thing is, you can use Kafka, but the use case should match something like this. What I have given the use cases. For example, in LinkedIn, what they are doing, they are pushing the metrics and the log aggregation, logs from all the servers to the Kafka, and from the Kafka, they are pushing to the Hadoop system, to the HDFS. So when they are pushing to the SDFS, on top of SDFS, they are running the filtering, cleaning the logs, and then they are doing the analytics on daily basis. So you can connect Kafka to Hadoop also. And the second question was with Dilip, can we connect with Storm also? Yes, Storm is also one of the mostly used real-time processing tool. So Kafka is a kind of tailor-made for Storm. That's why even in Storm, you can see in Storm spouts, There is a specific spout which is dedicated to Kafka. They have developed one simple label consumer of Kafka, and they are calling that as a Kafka spout to read messages, to consume messages from the Kafka. It will come with Storm package. Difference with Storm and Kafka and Storm Spark streaming from Loknath. So the guys, this is another question from Loknath. He's asking like what is the difference between Storm and Kafka and Spark streaming? Basically, there is a difference between Storm and Spark, but there is no difference between like Storm and Kafka and Spark, because the way you are processing your data, it totally depends on your processing engines. So there are differences between Storm processing and Spark processing. This one thing is real time, the other thing is batch. Even though it is working in real time, but it is analyzing the data on the basis of batches. In memory, Storm is not in memory. So this is difference between Storm and Spark, and we can see more in detail when we'll go in detail in this these things, Storm and Spark. Regarding Kafka, for Kafka it doesn't matter whether it is working with, it is integrated with Storm or it is integrated with Spark. Basically, it doesn't bother about, it doesn't maintain any state. Who is consuming and till what they have consumed and what is the next they are trying to consume. Kafka doesn't maintain that state. So for Kafka, consumer doesn't matter. It always up to consumer when they can come and they can consume the messages. Is scalability is the only difference between Kafka and other message queue systems? Nishant, scalability is one of the factor, one of the major factor, because you need something which can easily scale out for as per your load. And second thing, reliability I'm saying because in when you're getting the data at that high speed, you start writing in RAM. When you start writing data in memory, there's the chances of losing the data, if not much, but at least there are some chances of losing the data. In Kafka is having very good reliability, and they're writing messages to the logs, they're writing messages to the disk. Each and every message they are writing to the disk. So there is a reliability there, you don't lose any data there. With this Storm also we can do real-time streaming. So how Kafka is specific in stream data processing? Dilip, I'm not. I think till now what I have said is like we are not doing any processing in Kafka. Kafka is a tool to support your data pipeline where you can store your messages and you can forward to your processing engines. So your Storm is the one who is doing the processing, but Storm cannot process the data which is coming at very high speed to Storm. You need to store the data somewhere so that Storm can take data one by one, tuple by tuple, and they can process it. Because when you're processing something, you take time. When you take time and the data which is at one side, data is coming in millions of messages per second, your application is generating at that speed and your Storm is processing like 20,000 messages per second. So there is a difference, so that difference somewhere you need to fulfill. So Kafka is fulfilling that place, it's fitting in that place. Abhishek, the next question is Abhishek from Abhishek. Why RabbitMQ is not suitable for use case you listed? The first case itself, uh, Abhishek, it is not fitting transportation of log in real time. So in real time, when I'm having a data which is coming at very high speed, the RabbitMQ speed is around 20,000, 40,000 messages per second. And as per my load, currently I need a messaging broker which can handle millions of messages per second. So this is something which we cannot expect from RabbitMQ to do. So and also when you want, as per your load, if you want in future, if you want to increase the scalability of the system, I mean RabbitMQ it's tough, even though it is distributed, but it's not so easy as is Kafka. In Kafka, without impacting your existing cluster, you can add more nodes to the cluster and you can cope up whatever the load you have, you can continue working with the same without bringing down your entire cluster. Next question is from Harish Bajpai. Kafka works in memory, in memory. If yes, then why? What may be size of RAM? No, Kafka is not working in memory. Harish, Kafka is writing each and every message to disk. What is the need of a store in broker? Why can't data be passed directly to the processing engine? Ajit, just now I explained to someone, I think to Dilip, the same thing. Your processing engine will take time. Your processing engine cannot process at that speed what your data you're getting. So you need to store the data. You need to fulfill that data pipeline. So for that reason, you are storing something. You're storing data in Kafka, and later on your processing engines are consuming that data, and after some time, your every data is having one ETL and time to live, or you can say TTL, and after the TTL, their messages are getting deleted from the Kafka. We'll cover it later, how it is getting deleted and all. Can we use Kafka for point to point or only for publish subscribe? Sudarshan, Kafka can be used in both ways. Either you can use in a traditional way point to point, or you can also use as publish subscribe. It totally depends how you have designed your consumers and consumer groups. Okay. Next question is from Navandita. No, sorry, I'm sorry. Namnita. How long can Kafka hold the messages? So Kafka have one configuration that is called as retention period. So it is up to you. By default, it is 7 days, but you can go and configure for 1 day or 2 days as per your wish, and the message will be there for that long in Kafka. Kafka is basically the best option for publish consume when there is lot of events and ecosystems such as Hadoop where there is a volume high. Yes, Sunil. Nishant, not all are storing in memory, but when you are go for scalability, only those messaging queues who are giving you at that high speed, 20,000, 30,000, they are working with in memory. Writing on disk will not make it slow. Amol, that's what they Kafka is using some techniques for reading and writing the data to the disk, which is making it more faster. It is the performance they are giving the same as the messages are coming from RAM. So there's the latency is like 2 milliseconds latency, 3 milliseconds latency for a single message for writing the message in disk and reading the message from the disk. What is the limitation of Kafka? Kafka, they have limitations, Kafka also, but it for real-time data processing, they do not have. They have the dependency with Zookeeper, which they have resolved in a latest version of Kafka for maintaining the offsets. Because Kafka, there is a possibility like your consumer can consume the same message multiple times, because Kafka is not maintaining the state. So your consumer is maintaining the state. If they are coming with the same offset number, they can consume the same message. So guys, I'll take the questions at the last. So this is something like quick introduction, and looks like you all are coming with questions. So we are on the right track. Now on next questions I'll take once we are end of the session. They maintain their own queue. So how Kafka is reliable? Nishant, they maintain their own queue, but that queue is in logs. It's not in memory queue. It's a log file in the system, in your broker systems. So 9:20. Okay, I'll take the questions in the last so that we can continue. So what is common for your messaging brokers, messaging systems, and your Kafka? The first thing is scalable. Need to be highly scalable. A lot of data, it can be millions of messages. This is the first difference. Reliability of messages. What if I lose a small number of messages? Is it fine with me? This is something which I was talking about to few guys. Yes, even RabbitMQ is very good. It is distributed, but the in memory part is something which is a problem. We may lose some data, even though Kafka is broker distributed, and you can add brokers or nodes to the cluster, Kafka cluster on the fly. Multiple producers can write to your Kafka broker. At the same time, your multiple consumers can consume the data from your Kafka. High throughput doesn't need to have JMS standard, as many may have overkill for some use cases like transportation of logs. This is JMS, where JMS has to, like, each and every message has to be acknowledged, and because of this acknowledgement, this is getting slow. Your messaging queues are getting slow. Here in Kafka, you can work with both. Either you can go with uh, no acknowledgement async mode, where you will not get acknowledgement of any message, or you can go with acknowledgement where each and every message will be acknowledged. And there also they have two categories. Either the first, if you have cluster of 5 nodes and you have replication of 3, so if you can go with like once the message is written to a single broker, give me acknowledgement. Don't wait for all 3 replications also to be committed. Give me the acknowledgement once one of the broker is having the message. So this is something like which is was different, and this is good compared to your messaging queues. X, you do not make X in Kafka. You you just push messages to the Kafka, and you need to configure your Kafka accordingly. Whether I need to act, whether my broker has to act for this message or not. The way you will configure your system, your Kafka will act accordingly. Programmatically, you need not to act something, because you're not receiving your application, you're giving message to the broker itself. I'll talk about what is broker and all. So why LinkedIn built Kafka? As we all know, like Kafka was built in LinkedIn. They started with Kafka, and then they later on they donated Kafka to the Apache, which was later on added to the Apache projects, Hadoop projects for real time, and now it is one of the mostly used or critical component for data pipeline, real time data pipeline. So why did they build Kafka, and what was their design areas, like where they were focusing? So for them, the first important thing for them was to flow data into data warehouse, to send batches of data into our Hadoop workflow for analytics. This nothing, whatever the logs they have, whatever the data they are generating, they wanted to push the data back to SDFS, where they can do some analytics on top of that data, to collect and aggregate log from every service. So if they have 10 services, 20 services which are running on different containers, so the role of Kafka was like to collect the logs from all the different containers and push to Kafka. From the Kafka, they were using an application like Camo or Goblin. Now, earlier it was Camo, and now they started using Goblin to pull the data from the Kafka and push to SDFS. On top of that, they can run some kind of algorithms or analytical algorithm to analyze the data, to collect tracking event like page views. And this is nothing but this is activity log tracking, what the users are doing. So they wanted to track that also, to queue their in-mail messaging systems, and to keep their people search system up to date whenever someone updated their profile. So these are some cases where everything is like the data they wanted to analyze very quickly. So in that, when they want to analyze something quickly, they want to have the data quickly, they can send data for the analytics, so or processing part engine. So once the data have for processing, they can process it, and then they can update the system accordingly. Kafka is LinkedIn. So currently in LinkedIn 2014, this is old data, as one of the sites from the LinkedIn, they are telling like they have 350 plus Kafka brokers, and in that 8,000 topics. Kafka brokers, in terms of Kafka, the server is called as broker. The server is called as broker, and the application which is pushing messages to the Kafka is producer, is called as producer, and the application which is consuming the messages from the Kafka is your consumer. So this complete Kafka terminology is around with three applications of three terms. Like first is a producer application which is pushing messages to the Kafka. Then there is Kafka broker. There's nothing but Kafka broker is your Kafka server. In other world we call it server, but here we are calling it as a broker because this is message broker. So this is brokers, and your consumer is the application which is consuming the messages. Next, 8,000 topics. 8 topics are the name under which you are writing your categorizing, you're giving some category kind of thing for your messages. Okay, these are my matrix messages, or so you are creating a name, a directory where you will store all the messages regarding or your matrix. Where my producer sits, whoever is trying to push messages to Kafka can actually work with Kafka. It can sit anywhere in cluster or outside cluster also. It could be real-time application also. 14,000, 1,40,000 or 140,000 plus partitions. So guys, focus this term like topics and partition are the core performance criteria, or you can say concepts for your Kafka. Why Kafka is such a fast thing. So let me will explain these two topics at the end because I want to explain with producer and consumer topics and partition. For now, you can understand topic is something which is a unique name given to a different type of messages. You're calling them, this is my this at this particular place I'll store only these type of messages, so that you can categorize in your Kafka if you want to use different consumers to consume different type of messages that way. 278 billion messages per day. So you can see this data is very huge. 278 billion messages per day. You can go for seconds and then you can see like how many million messages they are receiving every second. 49 TB day in, 176 TB day out. There's something which is coming from your Kafka or LinkedIn. The Kafka, the way it is performing, and it is keep on growing. Peak load 4.4 million messages per second, which is very huge. This messages per second, you can think like if message size is huge, this data is around 100 MB per second. 100 MB per second. I'm thinking about when you have data around 100 bytes and 120 bytes, then it can go around 100 plus MB per second. So this 100 MB per second is a huge speed. 6 gigabytes second inbound and 21 gigabytes second inbound outbound. So definitely this, the size, the message size, whatever the message they are giving 4.4 million, that message size is more. I was assuming it is 100 bytes, but it is more. That's why they are having 6 gigs per second and 21 gigs outbound. Guys, I'll take those questions. Whenever you have doubt, just keep on writing. We'll take those questions once we have done with the webinar. I'll answer all those questions before ending the webinar. But let's finish the content and then we'll take the questions. So this is something which they have given. The LinkedIn has given like where the Kafka is there in their architecture, where they have so many applications and all the applications are pushing messages to Kafka. You can open this diagram after the session, and let me open it for you and then I'll show you where's the Kafka, how they are dealing with the Kafka. By the time I'll take one or two questions. Producer is what? A Java program or what? Producer is our API which is writing or publishing message to the Harish. This was your question. Like, what is producer? Is Java program or what? Producer is any application which is pushing message to the Kafka, irrespective of the language in which the API was written, in which that program was written. It could be Java also, or it could be C also, C++ also, Ruby, Rails, anything. Scala also. Python also. So any programming language where someone is trying to push message to Kafka, they are your producers. You can see there Kafka is giving clients in other languages also. They have client in almost all the languages. What are partitions? Karthik, I will cover this topic later on because I need to reach that slide. Just wanted to go to that link and see the picture. This is something what these our guys are doing. One of the systems, what they are doing, they are pushing all the log lines from their application and events to your Apache Kafka, and from their Kafka they have their own different algorithms like Druid and Elasticsearch for analyzing that data, and they are analyzing that data and later on they are representing that data. Oh, so here in this particular diagram, If you see, this is a place where they are telling this is the Kafka. But this Kafka, basically they, for everything whatever their application is collecting, they are pushing the all the data for their Kafka, for databases and Kafka. Where is else? It's not the so clear picture, guys. So this is one of the questions, Kafka is a distributed public subscribe messaging platform, or it can also work as a point to point. So guys, when you have multiple consumer groups, so if your all consumer groups are reading from a different topics or same topic, two consumer groups are reading from the same topic, it behaves like your publish subscribe messaging platform. When a single consumer group is there and they are trying to read from same topic, all the threads under one consumer group, then it is behaving like a point to point. So Kafka is a universal pipeline built around the concept of a commit log. So commit log is nothing, whenever log is getting any message, they are committing it, they are writing it to the disk. The process of writing the log to the disk or message to the disk is called commit here. So once this is nothing but concept of commit log. Built with the speed and scalability in mind, the way while LinkedIn built it, they built with speed and scalability in mind. Enable, enabled near real-time access to any data source, empowered Hadoop jobs, and allowed us to build the real-time analytics. This was the one thing, because in real-time analytics you need to have the data for the processing engines in the real time, and not all the data to the real time, but the data which your real-time processing engine can consume and they can process. Vastly improved our site monitoring and alerting capability. So this is one of the use case where people are using Kafka these days. They are getting the metrics and all the data logs and everything from the system, and the real time using Kafka, then they are pushing to processing engine like Spark or Storm. They are analyzing the data and seeing like what is the state of the system. Whenever there is a from the matrix, they can find out wherever there is a change in the system, they can act accordingly. So basically it is helping them for a person to go and see all the metrics information or see the dashboards for all the information. It is always easy for a tool which can identify, because analyze in real time and tell, okay, this particular system is always increasing, the memory in the system is always increasing. That kind of processing analytics you can do with any real-time processing engines or Storm, from Storm or Spark. Enabled us to visualize and track our call graphs. This also, when you are having that data and you have the CDR, you can get your call graphs also, how we are doing or how the call stack trace is getting captured. So this is one of the question, like, okay, scalability, when you compare scalability of messaging broker and Kafka, you can see the difference is not less which you can ignore, difference is very high which you cannot ignore so easily. See the difference for producer, when you're writing, try to write something in Rabbit MQ or Active MQ, you can see the performance is coming somewhere lower. This is the matrix which is released from LinkedIn back in 2010. After that, even the Kafka was improved further, and other messaging systems also improved. So this is bit old data. So this, as when they developed, it was something like they were looking for high performance messaging broker, and your Active MQ was not giving 1,000. The message of supports they were giving were 1,000 messages per second. Then they started using Revit MQ, and Revit MQ was something better, and they were going till 20,000 messages. And the last, they went for Kafka with single batch. Kafka with single batch means you are trying to write a single message, not a batch of message. You're trying to write a single message, then it is reaching till 50,000, 20,000 to 50,000, it was varying. But when they increase the batch size to 50, when they increase the batch size to 50, same Kafka, the performance increased, and it went to 5, like something like that, 500,000 messages per second, which is huge with single broker. With single broker, if they can keep on increasing the brokers, this performance was increasing further. Next, consumer, how the consumer was working in that time. So consumers, you can see like for your active MQ, it started with slow, but after that it was somewhere stable around 6,000 messages per second. When you talk about Revit MQ, they started with 6,000 messages, consuming 6,000 messages per second, but slowly they were reducing and they were under 5,000 messages per second. Whereas Kafka, it was somewhere consistent around 23 to 24,000 messages per second. You can still see the difference. You are able to put 500,000 messages per second and you are able to consume only 25,000 messages per second. So if you give this type of processing, because totally depends the way you are consuming the messages. The messages have to come from disk, and which is still better from other messaging engines. How is fast is Kafka? We have seen this from Kafka. Up to 2 million writes per second on 3 cheap machines. Cheap machines, I think the person who is working in Hadoop, they might be aware of this fact, like most of the Hadoop projects or Hadoop ecosystem are running on commodity hardware. So using the same commodity hardware, you can run, and with 3 brokers, basically you can get 2 million writes per second or 2 million messages from producer per second. Sustained throughput as stored data grows. Second thing, whenever the data size is growing, you're continuously writing to brokers, but still your consumer performance is not impacting. Still you are getting the same consumer performance. I think this is the point where you guys were asking also, why Kafka, if Kafka is doing so much of IO, why Kafka is so fast? Because we all know when you are doing IO, there is a IO overhead, which is causing delay, which is causing latency. But Kafka is using two concepts for writing the data and for reading the data. First thing is, when Kafka passes all data to disk, essentially all writes go to the page cache of the OS, that is RAM, and from there they will go and write to the disk. But more than that, thing is, Kafka uses sequential writing, sequential access. What is sequential access? Sequential access says when you're writing something in disk, if you keep on writing in the uh, nearby data in disk in a sequentially in the disk, then probably while reading you can read in the same order. Then in that case you will not go seek for the seek operation in disk. You will not search the data in the disk. You'll access the data in sequential manner. So this, because of sequential, it is saving your time for seek, disk seek, and also for reading the data. This is something which they are using for write to make write much faster. Second, for reads, what they did, they started using a concept from the kernel, that is send file. So in that case they are avoiding all the context switching from your application to your kernel context. Generally the data, how we are reading the data is, the data has to come from disk to your kernel context, then kernel context to your application context, and from context then it will go back to network context, and network it will send further for your consumer application. So basically there were two context switching which was happening from kernel to your application context. So using send file you can directly give the network's address, and it can directly, kernel can only directly send to the your socket. The all the application switching is escaped. For example, this very good article on zero copy. This is the same concept what they are using. So if you see the data is coming from disk, the same data first it is going in kernel context, then kernel context is giving to your application context or application buffer, whatever data structure you're using for that data structure, then again it is going back to socket buffer and then your network. So basically you are doing two context switching there. So what they did using send file, now whenever you have to give the send file or transfer to method indirectly, what they will do, they will directly kernel context directly it will send buffer to socket buffer. So the switching which is happening from your kernel context to your socket will be your to application context, and application to socket is gone, and the time which we were wasting there is also gone. So this was the two basic techniques which they were using, and they were making your Kafka fast. Combination of two, fast Kafka. That's what, if you're fast writing, if you're fast reading, you are good. And because of sequential access, what they did, they are doing, first they are able to read the message faster from the disk, and then in disk also they know if one of the consumer is consuming the message as in the message number 1, then next time they will go and consume message number 2, 3, 4. So what Kafka starts doing, like it has one configuration which is called as fetch size. It selects that fetch size configuration 10 or 20 messages and put those messages in RAM. So whenever consumer is coming, consumer is consuming the message from the RAM rather than from the disk, because because of being sequential access. So you cannot go and directly read something, you are always going with sequential. If you're going for directly, then that is also allowed, you need to go and directly go for that particular value, from there you are reading. That's why first message is slow. If you see the consumer performance, it starts with slow. Why it starts with slow? Here if you see, because first it has to give the offset to the consumer, I want to read from this particular onset offset. Once they have the offset one, then they can read continuously, and the where it is dropping is the point where it is giving chance to some other consumer, it is writing your offset value, then again your consumer is consuming. So this was something which they why Kafka is fast. So 99.99% of our time of data is coming from disk, cache and RAM, and only very rarely we hit the disk. This is because of your sequential access. How it works? So this is Kafka in between a broker and your producer. Could be anything, it could be some application, front end application, could be back end application, right? Some console standalone application also, front end any web application also. It could be anything which can write messages to your Kafka, and they can write in any language they want. They can write in any language they want, because your Kafka has given client APIs in almost all the different possible languages which they know, but not in the Lisp and Fortran and all, but the mostly the people, what people are using these days: Python, Scala, Java, C++, and even the web services also. Backend service, your consumer also could be any application which can directly go and consume the messages from the Kafka. Even Kafka can write messages to Hadoop and also your data warehouse. The first look, who is producer? The producer is something who is writing data to brokers, and consumer is someone who is reading data from brokers. They all this is distributed. What is data? Data is stored in topics. This data is nothing but our messages which we are pushing to Kafka. Topics are split into partitions which are replicated. Topics and partitions we'll discuss next. This is something which you need to focus a bit more, because this is not a generic term which you'll hear more. So topic is nothing but is a feed name to which messages are published. So this is a name to which you are publishing your message, you are writing to your message to that name. So this is a unique way where you can categorize your messages. Okay, all the messages which is coming from my matrix are coming under this topic. All the logs I will push to this particular topic name. All the data which is coming from some particular service or activity log I'll put to this particular topic. Now you have data under different topics. So in case if you have a different processing technique or different processing way which can read only these types of message, only matrix data, there's a tool Storm which wants to take data only from your matrix topic. So they can consume, they can subscribe only for that particular topic, and they can read data only from that topic. Whereas your other log you want to push to SGFS, so there you can write different consumer which can take data only from your logs topic, and that they can push to SDFS. So this is the way where you can uh, uh, categorize your logs or categorize your messages in Kafka. So basically this is a logical representation of topic. This is acting like nothing as a queue, but nothing as a queue, where you're from one end your producer will keep on writing the messages, from the other end people will keep on consuming the messages. So this is how they're telling, because why it is writing to the tail, because ultimately it is a file, and when you open a file, what generally where you will write in the file, you will write at the end of the file. This is something that Kafka prunes head based on the age, max size and key. And this is the head for the topic, like how much, what is the size, max size and what is the key or age of your topic, TTL. Next, this is something which are telling, like when you're writing to the from one producer at one end, and where are the different consumer groups. So consumer group is, what is consumer? Consumer is someone who is trying to read the message, and if you group few consumers, three or four type of consumers, where they follow the same property under one group, they are calling as consumer group. That is consumer group. It could have multiple threads, but you are combining those threads and you're calling that consumer group. So your different consumer groups can read from anywhere they want. Now how you will identify whether we are reading the same message again or not? Of, means your consumer is continuously consuming some messages from the Kafka, but next time whenever, because they will not get control always from the operating system where the consumers are running, so when they are not running and they are coming back after some time to consume the next message, they need to understand what was the last message they consumed, and from now from which message they have to start. To identify a single message in Kafka, we have one pointer. That pointer is nothing but called as offset. That pointer is called as offset, or you can logically you can say it is an ID associated with every message in Kafka topic. Every message ID related to any associated with a message in Kafka. So using this offset, they identify whether which message we have read till now and which message we will read now. Now what is partition? So partition, basically, if you, as I just now told, we are writing messages in disk. When you're writing something in disk or file system, you will write those in terms of files. So basically, you are writing in file. So if that file is called as partition, that file is called as partition. So if you create a single partition, means there is no more partition, only single file is there. So how many can read parallelly from that file? Only one. Single file, you know, right? If some one thread is open that file, other thread cannot access that file from operating system point of view. So when one thread is reading that file, others cannot. So what they did, they started giving you the partitions option. So you can create partitions to single file. You will divide that file in multiple files, small multiple files. So when you define multiple files, if you're creating 6 files, it means 6 threads can read parallelly from those files, depending on if you how many slots you have in your CPU, how many threads CPU can run parallelly there. So those many threads can work parallelly and they can consume data parallelly from your files. So partitions are added for providing you parallelism, where your multiple threads can work parallelly, either from producer side or from consumer sides. If you have partition of size 4, it means 4 producer threads can write parallelly to those producer logs, and same time 4 producer consumers can consume from those messages parallelly. So what is partitions? Partition is nothing but ordered and immutable sequence of messages that is continually appended. Means same file which is keep on appending for the producer. Producer will keep on appending the new messages, whereas it is immutable because we cannot modify anything as a consumer. So once the time to live is done for the messages, it will be deleted automatically by Kafka. Kafka will delete those messages. They will not be remain available for consumer to consume. Number of partition for topic is configurable. When you're creating the topic, you can create your number of partitions, how many topics we can create. Number of partition determines max consumer group parallelism. That's what here you can see. If you, there are two clusters, like, and they have total 4 partition, P0, P1 and P2 and P3. So basically if they have 4, it means 4 consumer threads can work parallelly, either from consumer group A or consumer group B. Offset. So offset is in partitions are assigned a unique per partition a sequential ID called the offset. So this sequential ID is nothing but this is giving you the name associated with every message. And how it is getting calculated. Like for example, the first message which is of 100 length, then the offset for the second message will become your first offset plus length of the message, so it is becoming 101. It is becoming 101. This 2 1 4, so these are the offsets. These are the offset. This is how your, this is second number message, this is one message, and this is the fourth message in partition 2. So these are associated with every partition. Next is a replication. In partitions, what are the replications? So replication means uh, when you have multiple brokers in the system, and one of the broker, there's a possibility like any of the broker can go down in runtime, could be JVM issue, could be your power failure, or any reason. If one of the broker is going down, and so whatever the data which was available on that broker is also going down, means the data is not available for consumer. So for to avoid this thing and to add more data reliability and durability, what they did, they started creating replication of the partitions. So same partition is replicated multiple brokers. So in case one of the broker is going down, you still have other brokers available from where your consumer can consume the messages. So broker does not push message to the consumer, consumer pulls message from the broker. This is something like how producer and consumer works. Producer will keep on writing data to the broker, but how it works totally is, producer will first, it will talk to Zookeeper. Zookeeper is there for coordination purpose, coordination between producer and broker and consumer for them. So once producer will ask, hey, give me the address for this particular broker, producer Zookeeper will tell, okay, this is the broker, and then your producer will start writing to that particular broker. Next, when your consumers are coming, the consumer will keep on consuming the message from the Kafka, the particular topic. They should go with the topic name, they should go with the offset value from where they want to start consuming. In case if it's the first, then they can start with the 0. If they have some specific number of offset they have, they can go with that. So once they are done with the consuming the messages, they can go and update the offset value in Zookeeper. Update offset value in Zookeeper. So next time when they are coming, they will take the updated value from Zookeeper and start talking to Kafka from that offset. They can start reading from that offset. This is something how they are started reading if they have multiple brokers. So P0, this is replica 1, and P2 also replica 1 on broker 1. Same P0 is replicated on broker 2 also, as well as only two replications they are saying, and P1 is replicated, sorry, P1 is replicated on broker 2 as well as on broker 3, whereas P2 is replicated on broker 1 and broker 3. So in case one of the broker is going down, for example broker 2 is going down, and your consumer is trying to consume the messages, then still they have P, P2, I should take marker. Okay, so here I'm saying like you have P0 and P1 on broker 2, and broker 2 is going down, and someone is there was a consumer which is trying to consume the message from P2, so they can go and talk to broker 1 for those messages. They can go and talk to broker 1, or for example they were taking message from P1, so they can go and talk to broker 3 for consuming the messages. If it is P0, they can go and talk to broker number 3 for consuming those messages. Overall, what I'm trying to say is they still have brokers from where they can consume the same messages for the same offset value. They will not get like whether the one of the broker is down or not. This operation will remain same for the consumers. Okay, so one of the example how we are using Spark and where it is sitting in this thing. So your Kafka, whatever it is, whether it is your application, web application, or you have data in your SDFS, somewhere you need some kind of processing technologies for process the data or for analyzing that data. This is something which either you're pushing data to SDFS, and from there you're using Hadoop and you're analyzing the data, or you're using Spark for analyzing the data. So Spark is a tool which is giving you the same functionality for analyzing the data, but it is in memory, so it is a bit fast compared to other Hadoop. So data ingestion source. So these are some source which one of the guys asking also, okay, why we cannot use Flume when the way we are using the Kafka. We can use Flume also, but Flume is not providing me that performance. Flume with memory channel, they are giving something around 4000 to 5000 messages per second. If message size is like around 1 KB, then it is giving like 6000, 7000. But when you talk about millions of messages, Flume is not giving that scalability to me. And also, Flume is giving this performance with memory channel, and memory channel is not reliable. If your Flume agent is going down, whatever data you have in your memory channel, that complete data will go down. So Flume is a good choice when you do not have that much high load, and if you are losing some of the data, and then also it is fine, then you can use Flume for that purpose. And there's one more issue with Flume is like Flume sits on the same server where you have your log files and others. If you're consuming from the log, then this Flume will add overhead to your application because it sits on the same cluster where your application is running. Okay, for Spark streaming, so from either of these source you can connect to Spark streaming, and Spark streaming can directly consume a message and write after processing, and they can consume back to SGFS or databases or dashboards. Next, streaming in detail. So what Spark streaming is doing with this is Kafka, like whatever data you are getting in forms of D stream, because your Spark, they are trying to analyze the data, they are trying to form the data in terms of batches. They are consuming or processing the data in form of batches. So when they are analyzing the data, they want to have the data in terms of batches, but they can directly talk to Kafka. They can get the messages in terms of streaming. They can club and wait for some time till the batch size is in reaching. For example, they have a small batch size for 4, because batch size should be small, otherwise it will not be big, it will not be real time. If you want your processing engine to behave in real time, you have to keep your batch size small. So in your case, the batch size is like 4 5 messages, 10 messages. You can push those 10 messages to the Spark, and Spark can analyze the data and push back to either SDFS or databases or dashboard, whatever you want. In the same format, they can order that. Okay, and so on, we'll say Kafka adoption and use cases. So there are a number of companies who are using Kafka. Is Twitter, Spotify, is Lockly, Mozilla, LinkedIn, and so many other companies also, which are like not such big, but these are also using Spark. All the application monitoring, real-time monitoring companies also using. Okay, so I'm taking the question from Rajat, where my producer sits. So producer sits anywhere, wherever. From there you can push messages to your Kafka. It could be any application which can push messages to your Kafka in any language. Producer is what Java program unhashed. So this is I explained earlier also. So what are the partitions? Karthik, I think I now not got answer. So partitions are nothing but they are files where you're writing your logs to achieve more parallelism. So I need to write Kafka producer or install Kafka client in my producer system. Like if there is an external server from which the data is streaming, I need to install Kafka on the system. No, Rajat. Thing is, you need to install. So Rajat is asking like, okay, I need to write Kafka producer or install Kafka client in my producer system. Definitely, you need to write Kafka producer in your application code. So when I'm saying Kafka client, basically you need to use 4 APIs from Kafka client. There's a jar, separate jar. You can use that jar in your application, and there are 4 classes. You just need to use those classes and connect to Kafka broker, which is running on some different system, like normal client server architecture communication. So there's server which is up and running there. You need to communicate with that server, and then once the connection is established, you start pushing the messages to that particular broker. Why I'm saying client? Because your producer is a client to your Kafka broker. Karthik, what is the W dollar seriously? Oh, I didn't get this, Karthik. Difference between topic and partition plate. please take this in detail. Okay, Nishan, topic is the external name. It actually, if I'll go with the implementation of Kafka, your topic and plus your partition number is a directory. Basically, it is a directory under which you are going and you're writing your application. You're writing your messages. Sorry, just stopping the VM. So topic is just a just you can say category, the way to categorize your messages and logs. So an implementation wise, category name, a topic name plus your partition number is giving you a directory name where you are exactly storing a particular partition log file. For example, my topic name is test topic. Okay, test topic, and I have three partitions: test topic 1 2 3. So in Kafka is creating one directory which says like test topic underscore 0. This is for partition number 0. Under that it will store the file partition log file number 1. Because file name is same for all the partitions, so what they are doing, they are identifying on the basis of their directory name. I'll show that. What is partition, please explain. This is done. What happens if there is a network breakage between the Kafka producer and Kafka broker? Rajat, if there is no network between your Kafka producer and Kafka broker, definitely whatever the buffer or batch you are having in your uh, producer buffer, that will be there. But if there is no network, you cannot push message to the Kafka. There, the Kafka is not responsible for that. There is no network, then you cannot write to Kafka. What is Revit MQ? Dilip, Revit MQ is one of the most used or widely used messaging queue system, messaging broker system. What is the maximum mesh size? Maximum mesh size here you are giving something around 100 MB, but that is to use. You cannot give max size more than that 1 MB size. Sorry, 1 MB size you are giving the max size, max message size. But this is configurable. You can go and change that in message broker system. If my customer is providing data from external server but I can't write any client on that server, then where my Kafka producer will reside. So Rajat, in case if your customer is providing data, so he should provide the data in some forms, either in the files or somewhere, in any format they should provide. So if they are not allowing you to code in your application, definitely they should give the data in some forms, either in file or in database or somewhere. Then you can write a small application program which can read from those files, those whatever source he is giving you for the data, to read from that source, and you can push directly to Kafka. This is done, the written producer. What is replication factor by default? What is the replication factor by default? Replication factor by default is 1, and basically there's two conditions for replication factor. By default, if you're not mentioning, it is 1, and if you're mentioning, it should be equal to or greater than your number of brokers. What is that? Less than or equal to your brokers. It cannot be greater than your number of brokers. There's no point in replicating the same message in a same broker twice. So it should be either same with number of brokers you have or less than that. Data security in Kafka. You can apply your data security in Kafka when you're writing the data, Rajat. When you're writing the data to your Kafka, you can encode your data and then you can send to the Kafka. When you're planning to consume the data, at that point of time, you can apply your decoding logic. If Zookeeper goes down, Kafka also stops working. What steps we should take to avoid loss of messages? Kalpesh, in case if you are using Zookeeper for maintaining the coordination between the Kafka and for the Kafka states and consumer states, then definitely you should go with Zookeeper cluster. Zookeeper cluster. So in case if one of the Zookeeper is going down, still you have a Zookeeper server to coordinate. And in that's what the earlier this dependency was there, but in latest release they started like they can push, you can state the state, you can save the state of offset in Kafka itself, so you can avoid Zookeeper using Zookeeper there. Can you explain after Spark streaming fetch message from Kafka and then what we did with those messages, and then what is the role of Spark streaming then? Loknath, the once you're reading the message from the Kafka, the integration between Kafka and Spark is done. After that, it's all responsibility of your Spark streaming or Spark for processing those messages. Once you have the message in batch, you can store the message in RDDs, and from there read data from RDD and you can process that data. The what it depends totally on your business logic, what you want to do with that data. You have data in your processing engine. Geographically, where do Kafka cluster reside exactly? I mean, uh, to say that is there any limitation for the distance between them, Shraddha? No, Shraddha. As such, there's no difference. But the difference between the distance between your Kafka cluster, if it is more, maybe the performance which you're seeing, you will not get that speed, because the speed which you're saying between Kafka cluster and the Kafka consumers or producers, it's like you can see it's in gig messages per second. So your network should support that much gigs. If your network is having around 100 MB per second or 10 MB per second, then the Kafka cannot give you that performance. The network plays actually basically network plays a critical role there. Your network should support that much speed, that much performance. I just mentioned Windows as your window machine were not responding. Okay. I'm so sorry, Karthik. Yeah, this is Windows. Sometimes it happens. It is 16 GB, still it is crying. Can I encrypt my incoming data before ingesting using Kafka? Yes, Rajat, you can encrypt your machine, and you can also use compression codec. And once you after encoding, or you can do encoding on top of compression also. Kafka basic by default supports three compression. It's a snappy, zzip, and third one I don't remember. Basically, this supports compression, zzip, and snappy. But most of the time, people are using snappy because the performance of snappy is way better than any other tool. Can we store Kafka data to S3 or similar places after some time instead of flushing, just like the log4j line or appendix that rolls data? Yeah, you can do that, Karthik. But what is the point? You have already consumed the data, and if you want to put the data in some kind of S3 or SDFS or anywhere else, then you can write one consumer which can keep on pushing data to your that particular storage. But from Kafka point of view, they have given all the configuration for your log, how you want to maintain your logs. Because without consuming, you cannot take the data. The way Kafka it is writing data in form of bytes. So if you want to go through the data also, you will not get anything. If you want to directly copy the files from the Kafka to anything, you will not get anything. So you have to write one consumer, then write one consumer and take and push data to your storage, to your file system. It's a Rajat, in case if it is a stream, you can directly write source which can read data from that stream and push data to your Kafka. Because Kafka is server and your stream coming stream is also server, then they cannot communicate with each other. Ego problem, right? Servers between servers. They need one client, they need one slave to talk to them. So those two servers are having ego problem. They cannot talk to each other. On a lighter note, okay, if replication factor is 1 and if both the broker goes down where the copy has been made, how this condition will be taken care? So love, if your replication factor is 1, it means you are okay if you're losing some data. When you're setting replication, because this is your choice, you are going with default replication factor that is 1, it means is what Kafka is taking this as like you are okay if your data is going down. So if one of your broker is going down, it means your data is going. Once your broker is up, then you can start consuming those messages. Kalpesh, if we can set a state of offset in Kafka itself, what will the zookeeper role? Kalpesh, in older release, the zookeeper role was high, and zookeeper was used for coordination. But that's what they are trying to escape. They are giving the facility to write in Kafka also. But still in productions and everywhere people are using zookeeper. This is 8.2 version from where they started saving the states in Kafka, but still it's not in productions. There is a stream of data coming to Spark streaming. it will take some time for processing, for say 1 minute. My incoming batch is after every 20 second, so there will be a jam. Rajat, there will be no jam because you have your Kafka in between who is handling the data. So the way you are consuming the messages, you need to, this is your consumer, right? So you can consume the messages, and once you have your bag full, your consumer will not consume any more messages. What is the data model being used by Kafka to store the files? Sequential and direct write. There is no data model as such. Whatever the messages you are sending in bytes, it will take those messages and it will directly dump in the log files. Kafka doesn't touch your message, it doesn't open the message for them, they just take this as a form of byte and dump it. If we have single consumer group for a topic, then topic work as a peer-to-peer write. Yes, Abhijit. Then basically it works as a normal queue. What will be the best choice between Storm and Spark? Currently, Storm is better choice. Uh, why Storm is a better choice? Because Storm is in productions. Because Storm is there in productions and people are able to work with Storm easily. They are not facing any problem. And with the Spark, there are a lot of problems. Is any flag to indicate my consumer that there is a network between producer and consumer? Basically, these brokers are they are talking to Zookeeper for updating whether they are up or not. So once one of the broker is down, if there is no network, one of the broker will not be updated to Zookeeper. So when producer will try to talk to Zookeeper, Zookeeper will not be able to give any producer address. So in that case, they will suggest like there is no broker and they start giving the error message. So that case, you particularly you need to handle in your producer program in case the connection is down and when I'm trying to create the connection or I'm getting connection not accepted exception, I'm getting connection exception, then this is how either I will dump to the file or I'll delete the messages. It's in byte format. It's not readable format which you can directly read it. You can read one by one, and if you know the decode logic, you can read one by one and you can convert to string those bytes and then you can use it. So guys, this issue with my VM, it's not starting. Will not be able to continue this hands-on. Wait 1 second. Basically, the setting up Kafka. Kalpesh, that's what people are thinking that Storm is very popular and it's very famous also, and performance by it is also. But the people who are having a system in productions, they have to wait for some time because if you see there are so many articles mentioned this Spark is under development, Spark stream is under development. So sometimes when you start implementing you see like okay I need to communicate with this thing but there's nothing applicable for connecting to Spark and Kafka, there is only one consumer, and that consumer is contributed by some other developer, Deepak Bhatt. So some other developer is contributing for the consumer, and the consumer which is coming with the Spark is useless. Either it will read the duplicate data or it's not good. Sometimes it will skip the messages. uh, Rajat, that we can do, you can encrypt a few fields, selected fields, but in that case, this all, whatever you want to do, you have to do in a producer code because Kafka will not open that message. It will not do anything on that message. For them, this is just like some bytes you are giving, and it is dumping those bytes. Not a separate VM. Wherever you have, in case in your system, if you have Hadoop or big data VM, same VM you can go and download Kafka packages from Kafka side and untar your packages. Kafka needs two dependencies. The first dependency with Zookeeper. Zookeeper should be up and running, and then you can start your Kafka. Once both are up and running, you can verify with JPS whether both the are up and running. Kafka broker, you can see it is coming with Kafka is, you can see the process name as Kafka, and Zookeeper, you know, like queer quorum peer main, or you can see whatever as per depend on the version, the name is coming for Zookeeper. So once both are up and running, then you can start working with your Kafka. So working with Kafka requires nothing but you have to create one topic. So you have to create one topic, and once your topic is created, the simple commands in your Kafka bin directory, there are commands to create the topic. Once your topic are created, you can go and start you're pushing messages to the consumer, and or if you're using producer and consumer from different applications, you can start pushing message to the topic. So for example, I started using Hortonworks because uh, my VM was corrupted, so I started using this thing. So currently you can see my it is not up. My Zookeeper is up, but my Kafka is not up. You can go inside Kafka, and your Kafka, if you see, you can go in bin server start.sh. This is a script which you can use and config, and there is like server.properties. So you need to start with server.properties. So this is the command. Once you have your Kafka, you can see this way, it should be up and running. It will say like Kafka server 0 started. So this says like your Kafka is up and running. On the next system, you can do JPS and you can verify whether Kafka is coming in JPS or not. So this is a command. In your Kafka bin, you can get different scripts for which you can test your broker whether it's working or not. So this is one of the way to test your code. So JPS we saw like, okay, this Kafka is there, right? So Kafka is up. Once Kafka is up, then you can start creating your topic. So Kafka topic hyphen create is an option. Then you can go with Zookeeper. What is my Zookeeper? Localhost 2181, and my replication factor is 1, and partitions is 1, and topic hyphen topic, the best topic name. If everything is working fine, it should not take that much time. There's some problem. It's not integrated properly. It created the best topic, fine. So what this best topic is, if you see the way where I'm storing my Kafka logs. So if you go this directory in my Kafka configuration log directory, I have given this position. So just now you saw I created one topic which says like name is batch5 topic. So batch5 topic and 0, this is the position where I will store my logs or messages. And for example, you can see there are some topics which I've created earlier. This is my topic name, and this 1 2 3 4, these are nothing but these are my partition numbers. So in those, if you go in those particular partitions, there you will see a way how the log file where you will store your messages which you are submitting to the Kafka. Okay, let's if this is working fine, let's try to produce some. Kafka is giving you facility where you can use directly, and you can directly actually work with your submit something message to directly to your broker from broker itself, like console producer. So this is one command. At the same time, I'm starting one more way where you can start your consumer console consumer to consume the messages from there also. User HTTP. So this is my consumer which is listening on this particular topic. What are the messages are there, and this is my producer. So let's say producer is running. I'm message hi, hello, how are you. So I'm trying to push messages here, and you can see those. What is so for first message it took some time, and after that you will immediately you'll start pushing here, and this message will keep on coming here. There is no delay there afterwards. So this console consumer and console producer, these are the scripts which Kafka has given you to verify your cluster, whether my cluster is working fine, everything is up and running or not. So you can verify with these topics. And in your bin folder you have a lot of scripts to like console producer, console consumer, Kafka topics, where you can describe and see what topics I have created, what is the configuration for my topics. You can alter those configuration for your topics, you can delete those topics. So all that management work you can do those using those scripts. Yes, Karthik, you can get these slides. Batch 5 topic. Okay, what are we specifying offset, where are we specifying offset for the consumer? Rajat, in this particular case, because this is not, I have not written any consumer, I'm consuming from beginning because this is console consumer, and it is very simple consumer. It just either starts reading from the start or it's reading from the latest. When you write your own consumer, then probably you will need to go with proper consumer offset value. So guys, that's it for the session.